Hello everyone, my name is Camille, and in this video I'm going to talk about Assignment 2 for Comp 3132. So firstly, we're just importing the pandas library and NumPy for data processing. Then we are storing this iris.csv in a file name variable, and then we are reading that file and we are displaying the first 5 rows. Then we are mapping uh, the name of the species into a number because neural networks cannot work with the text label, so we have to convert them to numbers. So for example, we have Setosa as 0, versicolor as 1, and Virginica as 2. Then we are displaying the first 5 rows again. As you can see, it's mapped correctly now because we don't have the name anymore. We have the respected number. Then we are keeping these input features in the x variable, which is the first 4 columns, and the target label in the y variable, which is the last column. Here we are splitting the data into X-train, X-test, Y-train, and Y-test, and we are splitting the data set into 80% training data and 20% testing data, and we are giving it random state 1 to 3 just to keep it consistent. Then we are uh, displaying the first 5 rows in the X-train, X-test, X Y-train, and Y-test. Then here we just knowing that we have 120 training samples and 30 testing samples. And here we are converting the class labels to one-hot vectors because neural networks perform better when we actually convert them to one-hot vectors. And that helps the model output probabilities for each class. And here we're just declaring our model, and our model has 3 layers. The first 2 layers they're using ReLU because it trains faster, and the last layer it uses softmax to produce class probabilities. And here we're just compiling our model. For the optimizer we're using RMSprop, and loss function is the categorical one, and we're using that because we have multiple classes and we want from the metrics we want the accuracy. And here we're just training our model, and as you can see here we are training the model 20 times on our datasets, and the accuracy is started as 46% with the loss of 97%, but as we go down it's actually pretty good because now it's almost 93%. And then we are testing the accuracy, and as you can see here it's 96%, which is really high. And here we're repeating all what we have done so far, but the only difference is we are decreasing the hidden units to 10 instead of 100, and we are keeping the compiler as is, not changing anything. But while we're training the model, we are changing the epoch to 4 and the batch size to 10. So as you can see here, the accuracy is not that good. It's only 28%, and the loss is almost 190%. And to answer this question fairly quickly, how the number of layers or hidden units could impact the accuracy of our model. Simply, when we have more layers, it helps the model to learn complex patterns. So that's actually how it affects it. Do we always suffer from overfitting? No. Overfitting happens when model memorizes training data and perform poorly on a testing data. And how we can detect overfitting? So simply if our training loss decreases while the training accuracy increases. And how we can reduce overfitting? We can add more data, we can add dropout layers, regularization, and making the model simpler. And for the last question, here we just have to change some of these inputs to our model. So for example, I added one more layer here and I changed the optimizer to Atom. I kept the loss function as is and I changed the epochs to 40 and the batch size to 5. And then the final result that I got was impressively good. It's 99%. And that's it for this assignment. Thank you for watching and have a good day.